our planet, a home that shelters life in the endless darkness of space. Do you think it's in trouble? In the darkness of night, green and purple lights drift across the sky, creating a breathtaking spectacle called auroras. But these lights, they are not just a beautiful natural display. They are a message sent by the sun from 150 million kilometers away. In 1859, a telegraph operator witnessed something unbelievable. A telegraph, completely unplugged, suddenly came to life on its own, using the electricity carried by the aurora.
Oh my God.
It was able to send and receive messages wirelessly for nearly 2 hours. Yes, you heard that right. A telegraph working without being plugged in. And these are the actual records of the messages sent that day. I know it sounds strange, but on that day, something truly unusual was happening in the sky. An event that would later be recorded as the Carrington Event. The story I'm going to tell you today is directly connected to the Carrington Event that took place in early September of 1859, and to the solar eruptions we are experiencing right now. When will the solar cycle we're currently in finally come to an end? And the auroras we've been seeing lately, those caused by increasingly frequent coronal mass ejections, or CMEs, are they merely a mesmerizing visual spectacle? Or are they signs of something much bigger approaching? Storms forming on the sun trigger massive explosions, and we divide these explosions into 2 categories. The ones that stay near the sun are called solar flares. During a flare, electromagnetic radiation and a huge amount of charged particles are released. The other type is far more violent, an event known as a coronal mass ejection. When a CME occurs, extremely hot atomic nuclei are hurled outward with tremendous acceleration, transforming into what we call a solar storm, moving randomly through space at speeds exceeding 2,000 kilometers per second. And because solar storms behave like shock waves, they continue generating more charged particles as they travel, allowing their power to remain stable along the way. If one of these CMEs turns toward Earth, it can slam into our planet within just a few days, depending on our position. If Earth had no magnetosphere, life as we know it could be wiped out instantly. Fortunately, thanks to our magnetosphere, the outcome becomes something far more harmless: the aurora, the northern lights, a visual spectacle we can actually enjoy. But these auroras are only the most innocent part of the sun's warning message. There is another side, a far more dangerous one, a remarkable natural phenomenon known as a geomagnetic storm. When a storm from the sun shakes Earth's magnetosphere, almost like stirring it violently, it generates electricity. And this phenomenon is what we call a geomagnetic storm. In other words, I'm talking about the massive electrical currents created by fluctuations in Earth's magnetic field. And as you can imagine, at the heart of every technology we use today lie electronic circuits. Engineers design these circuits and components to operate within safe magnetic limits, never ignoring safety factors. But the magnetic disturbances caused by a geomagnetic storm can be so powerful that they override those safety margins entirely, leading components to burnout, malfunction, or produce dangerous, unpredictable errors. In the mid-1800s, technology was limited, and the Industrial Revolution was only just beginning to spread. So a massive geomagnetic storm, back in those days, did not push the world onto an irreversible path. But today, things are very different. Health services, security agencies, emergency responders like firefighters, defense systems and military technology, banking and financial networks, manufacturing technologies, transportation systems, and even data storage, cloud infrastructures, electricity, and therefore the entire internet itself, are all systems that simply cannot function without stable power. And any event capable of disrupting these systems, even for a short moment, can pose a direct threat to civilization. Because our dependence on electricity is growing every day, geomagnetic storms now stand among the greatest threats to our future. For example, during the massive geomagnetic storm of 1989, Canada was plunged into darkness for 9 hours, and 6 million people were affected. And unfortunately, we may be living a critical period in which megastorms like those in 1859 and 1989 could have happened again. We thought solar activity peaked in August 2024, but it appears we may have made some slight miscalculations. Now, let me explain when a mega geomagnetic storm might occur and how we attempt to predict it. We call the sun's repeating energy cycle, the one that reaches its peak every 11 years, at a point known as the solar maximum, the solar cycle. The opposite phase, when solar activity is at its lowest, is called the solar minimum. There are roughly 11 years between each solar minimum as well. Of course, this cycle is a statistical value based on modern observation methods. It can vary slightly, but on average, 11 years remains a very meaningful number. Right now, we are in solar cycle 25. The points you see on the graph represent the number of sunspots. Earlier in the video, I mentioned solar radiation. After these electromagnetic outbursts occur, the regions where they happen and the areas around them become slightly cooler, appearing as dark spots on the sun's surface. These are what we call sunspots. The number of sunspots tells us how active the sun is. The more sunspots there are, the more active the sun becomes. NASA, NOAA, the U.S. National Oceanic and Atmospheric Administration, and the International Space Environment Service, ISES, regularly come together to analyze these data and to estimate the state of the sun's cycles, including when the next solar maximum will occur. They evaluate these measurements using 3 main categories of prediction models. First, purely statistical models based entirely on observation. Second, models using proxy parameters, such as the magnetic field strength measured at the sun's poles during solar minimum, the period when solar activity is lowest. And third, physical models simulated on computers using the known laws of physics. The main reason behind all this effort is simple. We still cannot observe the sun as thoroughly as we need to. There are, of course, projects under development, like Solaris and Firefly, designed to lighten this burden. and the Parker Solar Probe entered its solar orbit on December 24th, 2024, specifically for this purpose. But even so, the most reliable long-term record we have comes from the Wilcox Solar Observatory, which has been monitoring the sun since 1975. Long story short, this scientific panel released an update on October 15th, 2024, declaring that the solar maximum had been reached. But as you can see on the screen, there are studies suggesting that two solar maximums may occur, not just one. For example, in a study published in 2025 in the journal Astronomy and Astrophysics, A&A, titled Forecasting the Solar Cycle Using Variational Data Assimilation, Validation on Cycles 22 to 25. Eljuve and colleagues pointed out that most solar cycles exhibit two maximum peaks. Referring to cycle 24, they demonstrated, based on 13-month smooth data, that the delay between these two peaks can average around 2.6 years. Before we move on to the possibilities, I want to talk about the largest solar flare ever recorded, the geomagnetic storm that occurred in October 2003 during the solar maximum of solar cycle 23. This flare was so powerful that it instantly saturated measuring instruments, making it impossible for them to take proper readings. Later, blind estimation suggested that this flare may have even surpassed the strength of the Carrington Event of 1859. So what happened as a result of this massive outburst in 2003? Let's take a closer look. First, major communication disruptions occurred. Voltage fluctuations were reported in settlements across almost every region of the world. Northern countries were hit especially hard. Sweden was plunged into darkness for nearly an hour. Auroras, the northern lights, were visible across Europe and North America. GPS signals experienced severe disturbances. Aircraft were instructed to avoid northern latitudes, which significantly increased fuel usage, and therefore carbon emissions. Astronauts aboard the International Space Station were ordered to shelter in shielded areas, an extraordinary level of precaution. And finally, Japan's National Space Agency, NASA, lost its $570 million ADEOS-2 satellite, launched in 2002, after its solar panels failed, resulting in complete communication loss just 11 months after deployment. These are only some of the dangerous outcomes of what happened in 2003. So, even if we don't notice them, geomagnetic storms do cause disruptions somewhere on Earth. But unless something extreme happens, like a global blackout, they rarely make the news. Meanwhile, mainstream media and so-called science communicators, who disregard real science, continue to exaggerate these events. Because exaggeration attracts attention, and trends spread quickly. But these distortions ultimately undermine public trust in science at the most fundamental level. So, what awaits us in the future? In solar cycle 25, have we already experienced the solar maximum? Or could an even larger eruption still occur? In reality, there are two possible scenarios. Either the peak happened in August 2024, and solar activity has already begun its downward trend. Or, even though cycle 25 appears to have reached its peak, it may still produce a second maximum. one that could occur as late as the end of 2026, fulfilling the double solar maximum prediction. That means the next 12 months are absolutely critical for answering this question. Because when the charts are examined closely, we can clearly see that it's still too early to make a definitive judgment. The downward trend has not yet begun. The most important thing now is to understand the real risk. Because yes, living in such a technologically dependent era, the idea of experiencing a massive geomagnetic storm can sound frightening. But here's what matters most. The engineers who design the systems that could be affected take every possibility into account, including geomagnetic storms. And unless these storms reach catastrophic levels, they do not pose a threat to life on Earth. The chance of our everyday technological devices being affected is extremely low. The systems most likely to suffer disruptions are satellites, especially communication and observation satellites, and GPS satellites in geosynchronous orbits. Issues in these systems could impact military defense operations or global financial infrastructures. But even now, no worldwide catastrophe is expected. In summary, there is absolutely no reason to lose sleep over this. Even if a geomagnetic storm occurs in the future, the likelihood of it affecting you directly is remarkably low. And for those living near the equator, the risk is almost non-existent. Until the next video, take care.